Hello everyone, and welcome to College Algebra, aka Math 111. I'm Ms. Chan. I will be your instructor for this semester. I'll give myself a more formal introduction when we first meet, but however, let's just talk about math. Alright, so this is going to be the format of our class. Is I'm going to record our lecture, and then during our class time, we will go over questions and more examples if we have to. Alright, so before I get started on the lesson, what I want everyone to know is if you want to follow along with me, like have the same thing I have on the right side of the screen, all you have to do is go on Blackboard, go to Course Materials, Exam 1 Content, and then I'm going to label it by the section. So today we're going to be working on section 1.1, and then I'll have the date attached or named on the file. So the 17th is our first lecture, so I just named it 0817. Alright, I have the HTML version and the PDF, so whichever one you prefer. Alright, so let's get started. So section 1.1 is about linear equations and rational equations. Right, and the very first section of section 0.1 is to solve linear equations in one variable. But before we solve it, we have to know what is a linear equation in one variable. And that is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers, a does not equal 0, and x is the variable. This is also called a first degree equation because the variable x has an exponent of 1. Alright? So the main thing I want to point out here is that for the variable x, if we have a variable, you look at the exponent, and the highest exponent in that equation is 1. Alright? If it's a 2, if it's a 3, if the x is in the denominator, it is not considered a linear equation, and we'll go over examples with that in a little bit. Also, why can a not equal 0? If a equaled 0, then I would just have b equals 0, right? And so, but b is just a constant, all right? So it's very important, in order to be linear, it has to have the variable x, all right? So, but one last thing, but b can be 0. If I had just like ax equals 0, that's perfectly fine, all right? That just means b equals 0. Alright, so let's go through some examples. The first example I have is 2x equals 5. Alright, and remember our goal is for it to look like ax plus b equals 0. Or it can at least be written as ax plus b equals 0. Alright, so I have 2x and I have a 5, so I want it to look like this. So what am I going to have to do? I'm going to have to add a -5 to both of my equations. Right? And I'll explain why in a little bit. So when I do that, I get 2x minus 5 is equal to 0. Right? And as you can see, so the a is equal to 2 and b is equal to -5. So what does that mean? This means yes, it's linear. Alright? I know there's a 2 right there, but what I'm going to do, I'm going to do the odd numbers, 1, 3, 5, and then for 2, 4, and 6, we'll talk about that in class. Alright? So, this was number 1. Number 3, I have 1 over x plus 2 is equal to 0. Right? Some people might look and they're like, oh yes, this is linear. However, it's not, because x, this is ax, another way to write this, it would be x over 1, right? And this a over 1, because they're whole numbers. Alright, so this x over 1 is not the same as 1 over x, right? You can pick any number, pick a number. If I let x equal to 3, does 3 over 1 equal 1 over 3? No. Okay, 3 does not equal 1/3. Alright, so another way to write this if you didn't know, it would be x to the negative 1 plus 2, which is 0. Okay, when you look at this exponent, okay, the exponent is negative 1. Negative 1 is not the same as 1, so this is not linear. All right, and lastly, for today, or for just these examples, I have 7 minus 0.5x is equal to 2. All right, so our goal, remember, is ax plus b is equal to 0. So in order for my right-hand side to be 0, I'm going to add negative 2 to both sides, or we can subtract 2 from both sides. All right, when I do that, I get 5 minus 0.5x is equal to 0. Right? And if you want to be I can't think of the word, but if you want to be precise, maybe like you actually want it in this particular form, we can just flip it around, right? So keep in mind this negative, it goes with your exponent. So when I rewrite it, I have to bring that as well. This is minus 0.5x. Right? When there's nothing here, that means it's positive, so plus 5 is equal to 0. Right? In this case, our a is negative 0.5 and our b is positive 5. Right? So what does this mean? And look at the exponent. The exponent is 1, so this is, yes, it's linear. Right? You can go ahead and try doing 2, 4, and 6, and then we can talk about the answer on when we first meet, right? And then one thing I want to point out, this should be x plus 3 is equal to 1, right? So maybe it's going to happen early. I'll let you know now. I make quite a few typos. I try not to. I try to edit, but there's always that one thing I miss. And I guess this is another thing I'll mention, and maybe I'll mention it the first day again. But if you watch my videos and you notice a typo and you email me, I will give you guys, I'll give that person, whoever tells me, 1 extra credit point per mistake they see, right? And I'll put that extra credit point towards your homework grade. Alrighty, so now the second definition we have is a value for the variable which makes an equation true is called a solution to the equation. The set of all solutions to an equation is called the solution set of the equation, and two equations which have the same solution set are called equivalent equations. Right? So, for example, the value x is equal to 5/2 is a solution to the equation 2x equals 5. Right? So let me, in this little corner here, if x is equal to 5/2, how do we know it's a solution set? If I plug in 5/2 for x, I'll do that. Right? So these can cancel because there's on the numerator and denominator. This makes 1. 5 equals 5. Right? So that's true. So this is a solution set. Right? Another way to write this is with the squiggly braces, do 5/2. Right? If there's more, so this is the solution set, right? But if there were more, then what you just do is you would just separate them with commas, right? And then close them out. And then for equivalent equations, an example of that would be like x minus 1 equals 0, and then x minus 3 is equal to -2. Right? To show that, if you're unsure, we can add 2 to both sides, and we get x, let me do it a different way. Let's solve for x. So if I solve for x, this is x is equal to 1, and over here, if I add 2 to both sides, or add 3 to both sides, we get x is equal to 1. Because -2 plus 3, that's also 3 minus 2, so that's 1. Alright, so x minus 1 equals 0, and x minus 3 is equal to -2. This is considered equivalent equations. Right. So next up, we have the properties of equality. So first off, let A, B, and C be real valued expressions. So the addition property of equality is A is equal to B is equivalent to A plus C is equal to B plus C. Right? So that's why, like over here, okay, so my C in this case would have been the -5. And if I add it to both, these two equations are equivalent. Right? So here's an example. The 3x plus 2 is equal to 5. If I add -2 to both sides, then we get 3x is equal to 3. Right? And then the multiplication property of equality, A is equal to B is equivalent to AC, or A times C is equal to B times C, as long as C does not equal 0. Right? Because if C is 0, then you'll just get 0 equals 0 and just the equation is just destroyed. It doesn't tell us anything. Alright, so continuing on for pretty much solving for x, for the 3x plus 2 is equal to 5. For 3x is equal to 3, our goal is to have the coefficient of x to be 1. The coefficient is the number in front of x. And when you don't see a number, it's automatically 1. Alright, so the reciprocal of 3 is 1/3. So if I multiply 1/3 to both sides, I get x is equal to 1. Right? So that's the addition and multiplication property. Below here, it's the steps to solving a linear equation in one variable. Right? And then I'll talk about these steps when we do these examples. Right? So let me create more space. Right? And then so the first little topic on the pacing guide, if you follow that, it's solving a multi-step equation given in fractional form, examples. Right? So our directions are to solve for the variable and simplify your answer as much as possible. So example 1, we're given -34 plus x over 3 is equal to -8. Right? Ignore the purple. Right? That's just my solutions, so we can double check our work. Right? So for step 1, it says simplify both sides of the equation. So how do we simplify? We're going to do 3 things. We're going to use the distributive property. Use the distributive property to clear parentheses, combine like terms, and or consider clearing fractions or decimals by multiplying both sides of the equation by the least common denominator of all terms. Right? So we're looking at this example, and first we're going to look to see if we need to use the distributive property. Right? There's no parentheses at all, so we don't have to do that. Okay? The next one would be combine like terms. I look at it, there's no terms we can combine right now. Lastly, it says clear fractions or decimals by multiplying both sides of the equation by the LCD. Right? So I notice we have a fraction on the left side. Right? So what I'm going to do is I'm going to multiply it by the LCD. The LCD, in this case, we have a 3, and this is -8 over 1. Right? So the LCD is 3. Right? So in order to keep these equations equal, we're going to have to multiply 3 to the left and the right side. Right? If we just multiplied it by the left, we're not using the multiplication property of equality. Right? And it's not equal at all. Right? So let's multiply all this by 3. Okay? When we do that, we get -34 plus x is equal to -8 times 3, that's -24. Right? Step 2, so this was step 1. Right? Step 2, use the addition property of equality to collect the variable terms on one side of the equation and constant terms on the other. Right? On the left side, I have a constant and I have a variable, and on the right side, I just have a constant. Right? You could move the 24 over and then the x over on the other side, right? That's not wrong. However, if you want to do less work, what is usually the good rule of thumb is if there's one side with the variable and the constant, you usually just, and then the other, let me rephrase that. If there's one side that has both the variable and the constant, right, and then one side that just has either of them, you're going to add or subtract the common one. I hope that makes sense. So what I mean is there's a constant on the right side, right? So what I'm going to do is I'm going to add this constant over, right? Not the variable, because that's just even more work, right? So what am I going to do? I'm going to add 34 to both sides. When I do that, so we're going to check. So minus 34 plus 34, that's 0. So we're good. And then x just comes down, because we're adding it to nothing. And then negative 24 plus 34, that's also saying 34 minus 24, and that is positive 10. All right? So for step 3, use the multiplication property of the equality to make the coefficient, to make the coefficient of the variable 1. All right? But luckily for us, the coefficient of our variable is already 1, so step 3 is done. Okay? Step 3, that's done. So step 4, we're going to check the potential solution in the original equation. Right? We're going to do that because sometimes, 1, we might have done something wrong, or 2, it actually will not work. All right? So step 4, we're going to take the original equation, okay, but we're going to substitute x for 10. Okay, and does this equal negative 8? So negative 34 plus 10, right? This is negative 24. So how do I know that? So usually, because 10 minus 34, that's not as easy to think about, like as opposed to like 34 minus 24. But when the signs are opposite, what you'll do is you just subtract it like normal. So 34 minus 10, which is 24, and you take the sign of the larger number. In this case, 34 is larger, so I'm going to use the negative, right? Alrighty, and then negative 24 divided by 3, that is negative 8. And what do you know? This is equal to negative 8. So what does that mean? That means that x is equal to 10 is our solution set. So step 5, okay, our solution set is 10. Right? That is example 1. Alrighty. Now let's do example 2. In example 2, we are given 1/2 times the quantity 3/2 x plus 1, and the quantity minus 3/2 is equal to 3/4. Right? A lot of fractions. A little more complicated than example 1. But it's alright. As long as we follow these steps, we'll be fine. So the first step is to simplify both sides of the equation. Right? I look at the left side, there's a lot going on. I look at the right side, it's only one number. So luckily for us, we just have to simplify the left side because the right is as simplified as possible, right? So what am I going to do first? So I notice these parentheses and a coefficient in the front, so I'm going to use the distributive property, right? And when I do that, so 1/2 times 3/2, right? When you multiply, you just go across, so 1 times 3 is 3, 2 times 2 is 4, right? And don't forget the x, right? And then 1/2 times 1, that is 1/2. Righty? We're still not done with step 1 because we need to combine like terms. Because I notice on the left side we have two constants, right? So 3/4 x, and then 1/2 minus 3/2, right? You can just think of 3/2 minus 1/2, right? When you subtract or add fractions, you keep the denominator. 3 minus 1 is 2, right? But keep in mind, alright, and then 2 over 2, that's 1. Right, so 1/2 minus 3/2 is 1, but 3/2 is bigger, so it's going to be -1. Right? So now what I'm going to do, I don't like fractions, right? And actually what we could have done is we could have gotten rid of the fractions on this step, right? But it's fine. Okay, we can still do it here. So what we're going to do is, so the LCD, I have 4, 1, and 4. Okay, so the LCD is 4. Okay, so we're going to multiply everything by 4. Okay, and when we do that, we get 3x minus 4 is equal to 3. Right? So finally, this is as simplified as possible on both sides. So now we're going to start with step 2. Step 2, we're going to use the addition property of equality to collect the variable terms on one side and the constant terms on the other. Right? Just like above, we have the variable and a constant on the left side and a constant on the right side. So what I'm going to do is I'm going to take the constant on the left side and combine it with the right side. Right, to create the fewest steps as possible. So I'm going to add 4 to both sides, and I get 3x is equal to, and then technically I shouldn't have done that, so we have to check this. So -4 plus 4, that's 0, so that we did that right. Right, and then 3 plus 4, that's 7. Right, so in step 3, use the multiplication property of equality to make the coefficient 1 on the variable. Right, so there's a 3 here. Our goal is to make it 1. So to do that, what do we do? We're going to either multiply by 1/3 to both sides or divide both sides by 3. Right, either way, they're the same thing. When we do that, we get 3x divided by 3. That's just x, and then 7/3 can't be simplified, so that's it. Right, so now this step 3. Right, so now we got that x is equal to 7/3. Before we call it our solution, we have to check the solution, the potential solution. Right, so step 4, I have 1/2 and then 3/2, and then x, we have 7/3 plus 1 minus 3/2 is equal to 3/4. Okay, so remember PEMDAS, right? So I'm going to do my parentheses first. So in here I have 3/2 times 7/3, that is 7/2, okay, plus 1 minus 3/2 is equal to 3/4. Right? Still not done with the parentheses. So I have to add these. In order to add, I have to have a common denominator, right? So 1. So what I'm going to be a little lazy. Okay, I'm just going to erase this. And this 1 is just going to become 2 over 2. Right? And so this 1 and 2 over 2, it's still the same, right? Because if I divide 2 and 2 over 2, that's still 1, right? So I'm not changing I'm not changing the value, right? I'm just changing the way it looks like, so I can use it with, so I can combine it with the 7/2. Right, so I have 1/2, 7/2 plus 2/2, this is 9/2. Right. Okay, and then I'm going to multiply 1/2 and 9/2, this is 9/4, minus 3/2. Right, I already see ahead. I know I'm going to have to subtract these, but 4 and 2, they're not the same. So what I'm going to do, I'm going to multiply the top and bottom by 2 over 2. When I do that, I get 6/4 is equal to 3/4. Should not be putting equals. Have to question because we don't know yet. Right? And then 9/4 minus 6/4, that's 3/4. 3/4 is equal to 3/4. So therefore, we know, so step 5, our final step, we know that 7/3 is our solution. Right? And that is the first topic. And for the second topic, right, it's still part of section 1.1.1, right? So it's just the same thing we've been doing, but we're just going to take it a step further, right? So we're going to have multiple variables on multiple sides, right? But still, we're going to follow the same steps. So it's pretty much star 2. Example 1, we are given 5x minus 8 plus 2x plus 4 is equal to negative 5x plus 2. Right? So our goal is to solve for the variable, and we're going to simplify as much as possible. Right? So same thing as above, okay, but we just have more stuff to do. Right? So first I'm going to simplify both sides. So on the left side, I notice I have parentheses, so I'm going to distribute them. Right, so I have 5x minus 8, right? 3 times 2x, that is 6x, and 3 times 4, that is 12. Right? And then over on the right side, I have negative 5, and I have these parentheses, so I can distribute that as well. So then I'll get negative 5x. Negative 5 times 2 is negative 10. Right? Now, let's combine like terms. I have this positive 5x and positive 6x, so that makes 11x. Negative 8 plus 12, that's also 12 minus 8, so that's positive 4. Right? And negative 5 minus 10, I can't combine anything else. Right? So now on to step 2. We're going to use the addition property of equality to collect the variable terms on one side and the constant terms on the other. So unlike the other couple times, we now have variables and constants on both sides. Right? You can do whatever you want to do. What I normally like to do is I like to look at the variables, and I like to find the side that keeps my coefficient positive. Right? You can do whatever you want. Doesn't matter. You'll still get the same answer if done correctly, but I'm going to add 5x to both sides. Right? So I'll get 16x plus 4 is equal to negative 5x plus 5x, that's 0. Right? So we're on the right track, and then negative 10 gets brought down. Right? So I got all the variables on one side, now I have to get all the coefficients on the other. So what am I going to do? I'm going to add negative 4, or I'm going to subtract 4 from both sides. So I have 16x, 4 minus 4, that's 0, so that's good. And then negative 10 minus 4. So when you see that these both have the same sign, what does that mean? You can just add them. So negative 10 minus 4 is also the same as negative 10 plus a negative 4. So it's negative 14. Right? And then lastly, so remember, what is our goal? Our goal is to solve for x. In order to solve for x, the coefficient has to be 1. Right? We have a 16, it's not 1. So what do? We're going to divide both sides by 16. And when we do that, we get x is equal to negative 14 over 16. Right? Another thing we have to make sure is we have to make sure this is as simplified as possible. Right? Simplify your answer as much as possible. I see a 14 and I see a 16. When they're both even, what does that mean? It means they're both divisible by 2. Okay, so if I'm going to divide both top and bottom by 2, right? Because when you do that, you're essentially just dividing by 1. So it's the same thing. So this gives me negative 7 over 8. Right? So normally For step 4, we're going to check our potential solution. I already showed you guys that, so I'll let you guys check this yourself. But as you can see on the right-hand side, if you compare, they're the same answers. So I'm going to save us time by not checking it. All right? If you guys are against that, let me know, and we can check it together when we meet. All right? But as of right now, I'm just going to write 7/8. All right, and this is the solution set. Okay. So one thing, it might be confusing. Like when you see these, you might ask, what's the difference? Or, yeah. So the x is equal to negative 7/8. This is a solution. Right? So going back up here, it's the solution to the equation. Right? But the solution set, the one that I boxed, right? The set is when you don't have to show any variables, right? You just have this squiggly braces with the solution in there. Right? So keep in mind, this is called the solution, and this is the solution set. All right? So let's see. Right. So I feel like I don't want to keep you guys for very long. So what I'm going to do is I'll let you guys do example 2. If you want to do that in class, let me know. I'll be more than happy to. All right. But let's go ahead and and then here's this in-class problem. I also want you guys to solve this. This we're definitely going to be talking about when we meet. All right, but example 2 is optional. You just let me know. All right, so now let's go on to section 1.1.2, which is identifying conditional equations, identities, and contradictions. All right, so what is a conditional equation? A conditional equation is when it has one solution. So everything that we've been solving, these last 3 examples, those are called conditional equations because they have one solution. Right? So what does that mean? So it is true for one solution, and then for every other solution, it's false. So for the basic example of x plus 4 is equal to 6, we know that the solution is x is equal to 2. So what does that mean? Anything that's not 2 is not going to be a solution. So if I even pick x is equal to 0, I get 0 plus 4 is equal to 6. Then I get 4 is equal to 6. This is not true. Right? So for x is equal to 0 is not a solution to x plus 4 is equal to 6. Right? Contradiction, it means there's absolutely no solution. Right? Some equations will have no solutions, such as x plus 1 is equal to x plus 2. Right? There's going to be no value of x that when you increase it by 1, it will equal to the same value increased by 2. Right? So when you usually solve an equation, okay, remember from step 3, we want to use the addition property to collect all the variable terms and all the constant terms to one side. Right? So if we just looked at this and say that we didn't know that x plus 1 is equal to x plus 2, if we didn't know that was a contradiction, right, what we would do is I would subtract x from both sides. Right? So I get 0, right, plus 1 is equal to 0 plus 2. So that is 1 is equal to 2. Right? If you want, you can go a step further and you can bring all the coefficients, like all the numbers that's not 0 over, then you can get 0 is equal to 1. Right? But you can stop right here. Right? So we have 1 is equal to 2. That's a contradiction because 1 can never equal 2, and same goes for 2 can never equal 1. What does this mean? This means that the equation has no solution. So the solution set for a contradiction is the empty set, so you can denote that. So the solution set would look like this, or you can say this, which means that it's an empty set. All right? So what does that mean? This means that for x plus 1 is equal to x plus 2, no matter what number I want to put in here, it's never going to equal. So if I put x is equal to 0, I get 1 is equal to 2. If I say x is equal to 3, then I'll get 4 is equal to 5, right? If I say x is equal to negative 1, then we'll say 0 is equal to 1. It's never going to work, right? No matter, you could put infinitely many number of x's in there, and none of them will ever work. And that's what a contradiction is. Right? And lastly, the third option we can have when we're solving linear equations is an identity. An identity means that there's infinitely many solutions. Right? So what does that mean? It means that the equation is true for all real numbers. So this one is more straightforward because we get x plus 4 is equal to x plus 4. They're obviously the same. All right? So the left and right hand side, they're identical. So that means any real number that you substitute for x will result in equal quantities on both sides. So when you solve for x plus 4 is equal to x plus 4, then you'll get 4 is equal to 4. That's an identity. All right? So what does that mean? So for x plus 4 is equal to x plus 4, you can put any x you want. You can put 1,000,000. You'll get 1,000,000. 4 is equal to 1,000,004. You can say x is equal to 0, so then 4 is equal to 4. You can say x equals to 1, so you get 5 equals 5. No matter what x you pick, you can even pick 5 halves if you want. No matter which x you pick, it's always going to work. Right? So lastly, for the identity, so the solution, what you can say is you can say infinitely many solutions. I say SOLNS, right? Or even easier, you can write this R. So what it is, it's 2 vertical lines. So it's pretty much just an R with an extra vertical line. And that just means that's just the real numbers. All right. So now let's do some examples. Okay. So example 1. Okay, I have 3 and then x minus x plus 1 is equal to -2. Right? We've already talked about the steps for solving equations, and I showed a lot of work. For this one, I'm going to go a little bit faster, right? And then if you have any questions on what I did, just let me know. Okay, so what I'm going to do here is I'm going to simplify. I have these brackets and I also have these parentheses. Okay, so what I'm going to do is it's just when you see parentheses, you just go in and out. So I'm going to work with this first. So when I see this negative, but there's no number, it just means -1. So I'm going to distribute the -1 to both sides. Then I get x, and then -1 times x is -x. -1 times 1 is -1. Right? When I combine these, x minus x, that's 0. So then I get 3 times -1 equal to -2. Right, so -3 times 1, that's -3, is equal to -2. Right, -3 can never equal -2. So what does this mean? This means this is a contradiction. Ooh, that's bad. That's supposed to say contradiction. Right, so what is my solution? My solution is the empty set. Right? Example 2. And if you wanted to double check, so if you weren't really confident on what you did, for a contradiction, you can pick any number. Normally, if you want to test it, I'd probably do maybe 2 or 3, just in case. But if you even pick like x is equal to 0, then you'll get 0 minus 1 times 1, right? So that's -1, which you get -1 times 3 is -3. -3 is not equal to -2. You can also pick like x is equal to 10 if you'd like, right? But then you'll see that they don't work, right? So example 2, we have 2 is times 3x minus 1 is equal to 6 times x plus 1 minus 8, right? So what I'm going to do, we're going to simplify both sides of the equation. I'm going to distribute. So 2 times 3x is 6x minus 2, and then 6x plus 6 minus 8. Right? So I have 6x minus 2 is equal to 6x. And then 6 minus 8, that's negative 2. Right? If you notice right here, if these 6x minus 2, 6x minus 2, they're the exact same, you can automatically tell me that this is all real numbers, that this is an identity. Right? But the thing is, it has to be obviously equivalent. So if you tell me that this is an identity right here, I'm going to take off points because it's not clear to me. Right? It has to be the exact same. Right? You have to add the 6 and the negative 8 together. But if you don't see it, that's fine. What we can do is we can subtract 6x to both sides, and we get 6x minus 6x, that's 0x, minus 2. 6x minus 6x, that's also 0x, bringing down the negative 2. Right? As you can see, negative 2 is equal to negative 2. So then right there you can tell me it's an identity. Right? Either step, that's when you can say it's an identity. Alright? So example 3 is just like these examples up here, so I'm not going to go over it. Alright? But for example 4, if you want me to, just let me know. Alright? But for example 4, I want you guys to do it. It should be an in-class problem. Alright? And then we will talk about this when we first meet.